Hello everyone. So in this video, I am going to discuss the current electricity topic of class 10th. And in this video, I am going to discuss the syllabus, mind map, some keynotes, and some previous year question asked. So let's begin with the video. So this is the latest syllabus of class 10th. So in this video, we'll learn about the potential difference, electric current, Ohm's law, resistance, resistivity, factors on which the resistance of a conductor depends, series combination of resistor, parallel combination of resistor, and its application in daily life, heating effect of electric current and its application in daily life, electric power, interrelation between power, voltage, current, and resistance. So this is the mind map we have. So in this whole video, we'll learn about the mathematical relation of Ohm's law, some numerical problem on this, equivalent resistance in parallel circuit, equivalent resistance in series circuit. We'll learn how to find out the power of the circuit, Joule's law of heating, some symbolic representation of the circuit, diagram, resistivity and resistance, and we can see some circuit diagram through which we can calculate the equivalent resistance, current, and voltage. Let's move to the topic. So this is the first topic, that is electric charge. Charge is a fundamental property of matter, and due to which it produces or experiences electric and magnetic effect. The charge at rest creates electric field. Charge in motion creates electric field plus magnetic field, and charge in acceleration produces electric field, magnetic field, and releases energy. There are two types of charge, positive charge and negative charge. Negative charge is electron and positive charge is proton. And the properties of charges, like charges repel and unlike charges attract. So if I'm keeping two positive charges, they will repel each other. And the force of repulsion can be calculated by using Coulomb's law, that is 1 by 4 pi epsilon naught Q1 Q2 over R square, where R is the distance between them and Q1 Q2 is the value of charge. Now the charge on one electron is equals to negative of 1.6 into 10 raised to the power minus 19 coulomb, and the charge on proton is 1.6 into 10 raised to the power 19 coulomb. Coulomb is the SI unit of charge, and the total charge on the body can be calculated by using this equation. Q is equals to plus minus NE, where Q is the net charge on the body and N is the integer, where N can be 1, 2, 3, 4, and so on. It would be integer. It cannot be 1.5, 2.5, because whenever the electron is transferring from one body to another body, it is quantized. So it is transferred in a fixed quantity. Either one electron can be transferred, two electron can be transferred, 2.5, 3.5, 4.25 cannot be transferred. The charge on electron is given, and the total charge would be the product of number of electron multiplied by charge on electron. Next is electric potential. So let us suppose that this is the charge we have, and I need to find out the electric potential due to this charge at point P, which is R meter away from it. So to get the electric potential due to this charge, what we have to do is we have to take a positive unit charge at infinity, and if you bring this charge from infinity to this point P, the amount of work done by bringing a charge from this to this, work done per unit charge is given by the potential at this point P. So potential at P is given by work done while bringing a charge from infinity to point P per unit charge. This is how the electric potential is defined. So we assume that the potential at infinity is 0. So potential is measured in volt, and potential of 1 volt at a point means 1 joule of work is done in moving a unit positive charge from infinity to that point. Next is potential difference. So let us suppose that This is point A and B. So if I'm moving a charge from point A to B, so the amount of work is done per unit charge while bringing a charge from A to B is called the potential difference between these 2 points. Fine. So potential difference between the 2 points are the work done per unit charge. Fine. While bringing a charge from point A to point B. So the potential difference between 2 points in an electric circuit is defined as the amount of work done in moving a unit charge from one point to another point. So let us suppose that if we have a cell which has a potential of 6 volt, it means per coulomb of charge, we have to do 6 joule of work done while bringing a charge from negative terminal to positive terminal. SI unit of potential difference is volt, which is represented by capital letter V. And potential difference between 2 points is said to be 1 volt if 1 joule of work is done in moving 1 coulomb of charge in electric in one point to the another point. So 1 volt is equals to 1 joule upon 1 coulomb of charge. To measure the potential difference, the device which is used is called voltmeter, and the voltmeter has very high resistance and should be always kept in parallel with the resistance. So if this is the resistance we have, so the voltmeter should be kept parallel with the resistance. Now let's see the electric current. The rate of flow of charge is called electric current. I is equals to Q by T. So if let's suppose 1 coulomb of charge is flowing in 1 second through the cross-section area, then we can say that 1 ampere of current is flowing. Ampere is the SI unit of electric current, which is represented by capital A. Q is measured in coulomb, T is measured in second. Coulomb per second is called ampere. So 1 ampere current means 1 coulomb of charge is flowing in 1 second. There are some relatively smaller unit of electric current as well, like milliampere and microampere. So 1 milliampere means 10 raised to the power minus 3 ampere, and 1 microampere means 10 raised to the power minus 6 ampere. Let's see this. How do we measure the current? Current is measured by the device that is called ammeter, and an ideal ammeter has very low resistance, and it should be kept always in series with the resistance. So if this is the resistance and I need to find out the current passing through this resistance, so the ammeter should be kept in series with this resistance. Let's see this electric circuit. The path of electric current is called electric circuit. It could be either interrupted or uninterrupted. So if the path of current is uninterrupted, then this is called closed circuit. And if the path of current is interrupted, then this is called open circuit. Or we can say a continuous conducting path consisting of wires and other resistances like bulb, electric fan, etc. Switch between the two terminals of a cell or a battery along which an electric current flows is called electric circuit. See this symbol. So these are the symbol which is used in the circuit diagram. So this first symbol is cell, in which we are using two parallel lines. One is thicker line, another one is thinner line. This thicker line and shorter line is representing the negative terminal of the cell, and the thinner and the longer is representing positive terminal of the cell. So if you see the cell has two parts. One is the cap side. Cap side is representing positive terminal, and the flat plate side is representing the negative terminal. If we have two or more than two cells connected in series, then it will form a battery. A straight line is connecting wire. This zigzag line is a resistor, and this is the symbolic representation for crossing wire. This is wire joint. This is variable resistor or rheostat. Ammeter is represented like this, voltmeter with circle inside capital V, and galvanometer with circle inside capital G. These are the symbols for open switch or open circuit, open switch or open key, and this is the symbol for closed switch and closed key. And this is how the bulb is represented. Now, so the battery is a combination of two or more cells connected in series, and a variable resistance is also known as rheostat. Moving forward, circuit diagram. So in a circuit diagram, a diagram which indicates how different components of circuit have been connected by using the electrical symbol for the component is called circuit diagram. Let's see the direction of electric current. So if we have a conductor and this conductor is not connected with any of the electrical source of energy like cell or battery, then the free electrons of the conductor is moving in zigzag direction. So the net current produced due to this motion would be zero. Since they are not moving in a unique direction, so we'll be not getting any kind of current. But if we connect this wire with the cell or battery, then the electron started moving in a particular direction. So electron will be always flowing from negative terminal to positive terminal, and the current is always flowing from positive terminal to negative terminal. So this direction of current, which is from positive terminal to negative terminal, is called conventional direction of current. And the electron would be always flowing opposite to the direction of conventional current. This topic is very important for board point of view. Ohm's law. Ohm's law says that at constant temperature, the current flowing through a conductor is directly proportional to potential difference. Means V is proportional to I. So if we remove this proportionality sign, we have to add some constant. So this is the constant. So V is equals to IR, where R is constant and this R is called resistance. And this resistance is measured in ohm. If you draw the graph between voltage and current and voltage, so if we are dealing with the ohmic conductor which follows Ohm's law, so the graph would be always a straight line. And if you draw the graph of V versus I, where voltage is taken along y-axis and current is taken along x-axis, so the resistance will be given by the slope. V is equals to IR. If you compare this equation with y is equals to mx, which is the equation of a straight line, fine. So this m is the slope of resistance. Fine. So it means m will be giving you the value of resistance. So the slope of voltage versus current graph is giving us the resistance. Now, this is the question which is asked in board exam. So the voltage and current is given, and we have to plot the graph between current and potential difference, and we have to determine the resistance of resistor. Let's plot a graph. So I am taking current along y-axis in ampere and voltage along x-axis in volt. Let's take some suitable scale. So here we have 0 when current is 0.1 ampere, then voltage is 0.5. Then we have 0.2 ampere, 0.3 ampere, 0.4 ampere, 0.5 ampere. Similarly, we have 1 volt, 1.5 volt, then 2 volt, 2.5 volt. Now let's draw the graph. So when the voltage is 0.5, the current is 0.1. So this is the first point we are getting. When voltage is 1 volt, current is 0.2. When voltage is 1.5 volt, current is 0.3. So this graph would be your straight line graph. Now let us suppose if you are finding out the resistance, so for finding out the resistance, R is equals to V over I. We can take any of the value. V is equals to, for the first value, V is equals to 0.5 upon 0.1. Decimal get cancelled, so we'll be getting 5 ohm is the answer. Fine, you can take any corresponding value. If you take the second value, so V is equals to 1 volt and this I is equals to 0.2 volt. So it's 10 over 2, that is 5 ohm. Fine, so this is how we can find out the resistance of from the given data. Now let's see this. For verifying Ohm's law, we design an electric circuit diagram in which we show the arrangement of different circuit components. We find that with respect to the resistor, the ammeter is connected in parallel and voltmeter in series. Second option is ammeter is connected in series and voltmeter in parallel. Third option is ammeter and voltmeter both are connected in series. And fourth option, ammeter and voltmeter are both connected in parallel. So we know that in a circuit diagram, the ammeter should be connected in series with the resistor, and the voltmeter should be in parallel with the resistor. So this is how the circuit diagram looks like. So the correct option is B. Ammeter should be connected in series and voltmeter should be connected in parallel. This is also asked in board exam. Now let's see this VI graph of two conducting wire A and B are shown in figure. In both wires, if both wires are of the same length and same diameter, which of the two is made up of material of high resistivity? Give reasons to justify your answer. So the length and the diameter is same. Fine. So we know that R is equals to rho L upon A. Fine. So here we can see that the slope of this graph will give you the resistance. Fine. So slope of B is more than slope of A. It means resistance of B would be more than resistance of A. Since length and area of cross section would be equal, so resistance is depending upon resistivity. So RA would be equals to rho A L upon A, and RB would be equals to rho B L upon A. So if we divide this L upon A is cancelled out. We'll be getting RA upon RB is equals to rho A upon rho B. So from this graph, we can see that the slope of this B is more than slope of A. So RB is greater than RA. So we can say rho B would be greater than rho A. It means resistivity of B would be more than resistivity of A. All right. This can be also verified by taking some values. Let's suppose if I'm taking random value I. So for this, the voltage of the first one is smaller and the voltage of second one is larger. It means for the larger voltage through the B, we are getting this much amount of current. But through the A, we'll be getting the same amount of current with the smaller value of P. Got it? So it means that this will give you the same amount of current by the small potential difference, but this gives larger potential to give you the same amount of current. It means this is offering more resistance and this is offering less resistance. Now let's see this resistance. The property of a conductor due to which it opposes the flow of current through it is called resistance. The ratio of potential difference applied between the ends of a conductor and the current flowing through it is constant quantity called resistance. So resistance is equals to potential difference over current. It is derived from the Ohm's law only. V is equals to IR. So R is equals to V over I. Now, the factor on which the resistance depends upon the geometrical structure, that is shape and size, length, cross-section area, and it depends upon material, and it depends upon temperature as well. The SI unit of resistance is ohm, which is denoted by omega, and 1 ohm is the resistance of a conductor such that when a potential difference of 1 volt is applied to its end, a current of 1 ampere flows through it. Now, let's find out the relation between the resistance and resistivity. So resistance is proportional to the length of wire. It means longer the length of wire, larger would be the resistance. Is inversely proportional to the area of cross section. It means thicker the resistance, more the area of cross section, less would be the resistance. Or thinner the area of cross section, smaller the area of cross section, larger would be the resistance. So R is proportional to L upon A. If you remove this proportionality sign, we have to add some constant. So R is equals to rho L upon A, where rho is called resistivity. And this resistivity does not depend upon resistance, length, and area. It's an independent quantity. It depends upon property of material and the temperature of the body. So if you separate this rho is equals to R into A over L, where R is measured in ohm, area in meters square, and this length is in meters. Meters and meters get cancelled. We'll be getting rho is equals to ohm meter. Ohm meter is the SI unit of resistivity. So the resistance of all pure metals increases on raising the temperature and decreases on lowering the temperature. But the resistance of alloy like manganese, tungsten, and nichrome is almost unaffected by the temperature. The resistivity of the substance is its characteristics property. Resistivity is also known as specific resistance. This is important. The resistivity of a substance is equals to the resistance between the opposite faces of 1 meter length, 1 meter cube of a substance. And the SI unit of resistivity is ohm meter, which is written by the symbol omega and meter. The resistivity of a substance does not depend upon its length, thickness. It depends upon the nature of the substance and temperature. So by increasing the temperature, the resistivity increases for the conductors. See this question. What is electrical resistivity? So resistivity is a property of material. Fine. And it simply depends upon the temperature, and it's a property of material. Its unit is ohm meter. Rho is measured in ohm meter. And in series electrical circuit comprising a resistor made up of metallic wire, the ammeter is 100 milliampere. So current is given. Current is equals to 100 milliampere. If the length of the wire is doubled, how will the current in the circuit change? Justify your answer. So we know that R is equals to rho L upon A. If the length of the wire is doubled, then the resistance increases 2 times. So initially, let's suppose the resistance is R, which is rho L upon A. Now let's suppose the next resistance is, the new resistance is rho 2L upon A, which is basically twice of the initial resistance. Fine. So from Ohm's law, we know that V is equals to IR. So I is equals to V over R. Since voltage is constant, resistance is also constant. By increasing the length, the resistance increases 2 times. So the new current would be equals to I dash is equals to V over R dash, which is V over 2R. Means the current would be reduced by half. So the new current would be equals to 50 milliampere. So the resistance in the circuit can be arranged by 2 ways. This is called series combination and this is called parallel combination. In series combination, the same current flows and voltage divided. And in parallel combination, we have same voltage, but the current divided. Let's see this series combination. So in series combination, here we can see that there are 3 resistors which is joined with the same wire. When current goes from here, the same current will be flowing through R1, R2 and R3. So to find out the equivalent resistance of such circuit, the potential drop across this R1 is equals to V1, potential drop across R2 is V2 and potential drop across R3 is V3. Total potential supplied is V. So we can write V is equals to V1 plus V2 plus V3. Now V is equals to IR, where this R is representing the equivalent resistance, the total resistance of the circuit, which is equals to V1. V1 is equals to IR1 by applying Ohm's law. Since I is common for all, so we can take I as common. So this is what we are getting. R equivalent is equals to the algebraic sum of all the resistance. So this resistance is called equivalent resistance in series. So in series circuit, to find out the equivalent resistance, just we have to add them like we do in algebra. In series combination of resistor, the current is same in every part of the series circuit, and equivalent resistance can be calculated by adding all the resistance together. Current in the circuit is independent of the relative position of the resistor in series, and the equivalent resistance is greater than any individual resistance. Since equivalent resistance is sum of all the resistance, so obviously the equivalent resistance would be larger than any of the individual resistance. And the potential drop across each resistor is proportional to its resistance. Now let's see the parallel combination. In parallel combination, here we can see that the current goes like this, and the current has 3 ways to go. At this junction, the current will be divided. So let's say this I1 current is flowing this side, I2 is flowing this side, and I3 is flowing this side. And this junction and this junction has a potential difference of V. Now to find out the equivalent resistance, what we have to do is, since the current is divided and voltage remains same, so to find out the equivalent resistance, what we have to do is, we can see that this total current is equals to I is equals to I1 plus I2 plus I3. Now I is equals to V upon R. V is the total potential and R equivalent is the total resistance. I1 is equals to V upon R1, since voltage remains same. I2 is equals to V upon R2 and I3 is equals to V upon R3. Now this V get cancelled out by taking common, so we'll be getting 1 upon R equivalent is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So this is how we can find out the equivalent resistance in parallel circuit. Now let's see some features of the parallel circuit. So total current through the combination is sum of the individual current through all branches, as we have seen that I is equals to I1 plus I2 plus I3. The second is the potential difference across all resistors remains same. So V across all the resistance remains same. Next is the current through each branch is inversely proportional to the resistance of that branch. And the reciprocal of the equivalent resistance equals to the sum of the reciprocal of the individual resistance. This is how we can find out the equivalent resistance in parallel combination. If two resistors R1 and R2 are in parallel and their current is I1 and I2, then I1 can be calculated by using this formula, R2 into I over R1 plus R2, and I2 is equals to R1I upon R2 plus R1. Now let's see the disadvantages of series circuit for domestic wiring. So in series circuit, if one of the electrical appliances stop working due to some defect, then all the other appliances will stop working. Since if Any of the appliances not working, so it will make your whole circuit open. Fine. So all the component will not work. So let's suppose if the bulb get fused and you have series circuit in your domestic wiring. So in that case, none of the appliances will work. In series circuit, all the electrical appliances have only one switch due to which they cannot be turned on and off separately. Like in our home, we have parallel circuit, so we can operate all the appliances individually. We can turn on the light and let the fan switched off, fine. But this feature is not available in the series circuit. Either all the appliances will continuously work or none of the appliances will work. In series circuit, the appliances do not get the same voltage, fine, as the voltage get distributed. And in the series connection of electrical appliances, the overall resistance is very high, too much high, because in series circuit, the equivalent resistance is the sum of the individual resistance. Fine. So it will increase the resistance, due to which there is so much losses. We'll be getting less power. Now, advantages of parallel circuit. In parallel circuit, if one of the electrical appliances stop working due to some defect, other appliances keep working normally. In parallel circuit, each electrical appliances has its own switch due to which it can be turned on or turned off independently without affecting other appliances. In parallel circuit, each electrical appliances has its own switch due to which it can be turned on or off independently without affecting their appliances. And in parallel connection of electrical appliances, the overall resistance of the household circuit is reduced, due to which the current flows from the power supply is high. Let's see, this question is asked in board exam. The question is asking, calculate the equivalent resistance of the following electric circuit. So here we can see that this 10 ohm, this 10 and this 10 and this 20. So this 10 and this 10 in series, and their equivalent is in parallel with this 20. So let's say this is R1, R2, R3, R4, and R5. So first of all, let's find out the equivalent resistance of R3, R4. So R3, R4 would be equals to 10 plus 10 is 20 ohm, because they are in series. Now if you find out the equivalent resistance of R2, 3, 4, so it would be equals to how much? It would be equals to 20 into 20 divided by 20 plus 20 is equals to 20 into 20 divided by 40, so it's 10 ohm. Or we can use this equation as well. 1 by R equivalent is equals to 1 by R34 plus 1 by R2. So it's 1 by 20 plus 1 by 20. That is the LCM of 20, 20 is 20 only. Fine, we'll be getting 1 plus 1. So R equivalent of 2, 3, and 4 is equals to 20 over 2, that is 10 ohm. Now we have this whole circuit has an equivalent resistance of 10 ohm. Now this 10 ohm, this 10 ohm, and this 10 ohm are in series. So the total equivalent resistance is equals to this 10, and this 20. 10 plus 10 plus 20, that is 40 ohm is the equivalent resistance. This is the answer we have. Let's see this question. Study the following circuit in which the resistance are arranged in 3 arms A, B, C. Find the equivalent resistance in arm A. So in arm A, they all are connected in series. So the equivalent resistance of arm A would be equals to 5 plus 15 plus 20. That is equals to 20 plus 20 is 40 ohm. Now Calculate the equivalent resistance of the parallel combination of arm B and arm C. So R equivalent across arm B and C. So since they are in parallel, so first of all, we have to find out the total resistance in arm B and arm C. So if you see this, you'll be getting arm B has equivalent resistance of 15 plus 5 is 20 plus 10 is 30 ohm. And arm C has an equivalent resistance of 10 plus 20 plus 30, that is 60 ohm. So equivalent resistance of arm BC is equals to 1 by 30 plus 1 by 60, that is 60. Then this is 2, this is 1. So we're getting 3 over 60. It means RBC is equals to 60 over 3, that is 20 ohm. Determine the current flowing through the ammeter. So current would be equals to voltage is given, that is 6 volt, and we can find out the total resistance. The total resistance is equals to how much? Is equals to this 20 through BC and through branch A is 40. So the total resistance is 20 plus 40, that is 60 ohm, and V is equals to 6 volt. So we can find out the I is equals to V over R, which is equals to 60 over 6, that is 10 ampere. Now determine the current that flows through the ammeter when arm B is withdrawn from the circuit. So if you remove this, then the total would be in series. So the total resistance is given by 10 plus 20 is 30, 30 plus 30 is 60, 60 plus 20 is 80, and 80 plus 20 is 100. So total resistance for this question is 100 ohm. So I would be equals to V over R equivalent. V is equals to 6 over R is 100, that is 0.06 ampere. This is the answer we have. So the next is the heating effect of electric current. When electric current is passed through a high resistance wire like nichrome, the resistance wire becomes very hot and produces heat. This is called heating effect of current. From the definition of voltage, we know that voltage is equals to work done per unit charge. So work done would be equals to V multiplied by Q, where this V is equals to, from Ohm's law, V is equals to IR, and we know that I is equals to Q upon T. So Q is equals to I into T. So this becomes I square RT. So this is the work done. Now this work done is equals to the heat produced in the resistance. That heat is given by H is equals to I square RT. Fine. If you represent this I in terms of voltage and current and resistance, so from Ohm's law, we can say that I is equals to V over R. So if we put the value of this I, we'll be getting H is equals to V square over R square multiplied by R into T. So this R and this R get cancelled. So we will be getting V square over R multiplied by T. Or we can say V upon R is equals to I. So it would be equals to V into I into T. So H can be also calculated by this equation. Let's move forward. So a given current will produce more heat per unit time if the two resistors are connected in series than when they are connected in parallel. So since we know that in series circuit, the equivalent resistance is more than the individual resistance. So since the resistance is larger, the heat would be produced larger because H is equals to I square RT. So heat is depending upon resistance. Higher would be the resistance, higher would be the heat produced. In parallel circuit, the equivalent resistance is smaller than the total resistance of this individual resistance of the circuit. Fine. We know that in parallel circuit, 1 upon R equivalent is equals to 1 upon R1 plus 1 upon R2. So in parallel circuit, the net effective resistance is smaller than the individual value of resistance. So in the parallel circuit, we'll be getting less amount of heat. Now let's see this question. This question is asked in board exam. Write Joule's law of heating. The Joule's law of heating is given by mathematically it is given by this formula. So V is equals to work done per unit charge, and this work done would be equals to V into Q. Now this V is equals to I into R is equals to V, and Q is equals to I into T. So if you put the value, we'll be getting work done is equals to I into R, and Q is equals to I into T. So work done is given by I square RT. And this work done is equals to the heat produced in the resistance, that is H is equals to I square RT. So Joule's law of heating says that whenever the current is flowing through any resistance, it will produce the heat. And the amount of heat produced is proportional to the square of the current, resistance, and the time. Now let's see the B part of this question. Two lamps, one rated 100 watt, 220 volt, and another is 60 watt and 220 volt are connected in parallel to electric main supply. Find the current drawn by the two bulbs from the line if the supply voltage is 220 volt. So we have to find out the current drawn by the two bulbs. Let's see this. So we know that P is equals to V into I. So power is given 100 watt for the first bulb. 100 watt is equals to 220 volt multiplied by I. Fine. So let us suppose for the first bulb, I'm representing the current through the first bulb is I1. So this I1, P1, and V is common for both because they're in parallel. So P1 is 100 watt and I1 is the current through the first bulb. So I1 would be equals to I1 is equals to 100 over 220. This 0 get cancelled. So we are getting 10 over 22. So 10 divided by 22 is 0.45 ampere. This is the current through the first bulb. If we find out the current through the second bulb, we know that the P2 is equals to V into I2. So I2 would be equals to P2 over V. Now the power of the second bulb is given, that is 60 watt, and the voltage is given 220 divided by 220. So if we divide this, we will be getting 0.27 ampere. So this is the current flowing through these two bulbs. Now let's see the electric power. Electric power is the electrical work done per unit time. The unit of power is called watt. So we know that power is equals to work done upon time. And from the potential equation, we know that the potential difference is equals to work done per unit charge. So work done would be equals to potential difference multiplied by charge. So if you write the value of W, we will be getting V multiplied by Q over T. Now this Q over T is the rate of flow of current, that is equals to I. Rate of flow of charge is I. So P is equals to V multiplied by I. This is how we can calculate the power. The power is equals to voltage multiplied by current. And this can be also simplified into two ways. So power is equals to V into I. If you put the value of V is equals to IR, so IR multiplied by I is equals to I square R. So power can be also calculated by this equation, I square R. And the second equation is equals to V into I. I is equals to V over R. So we will be getting V square upon R. So the next formula is P is equals to V square upon R. In parallel combination, the voltage remains constant. So we can apply this equation for finding out the power. And in series combination, the current remains constant. So we can apply this formula for finding out the power. So here we have power in terms of current and resistance that we have seen in the previous slide. P is equals to I square into R, and P is equals to V square over R. Now let's see the power voltage rating of electrical appliances. So power rating P watt on an appliance means that it will consume electrical energy at a rate of P joules per second. For example, power rating of 100 watt of bulb means it will consume 100 joules of energy per second. So this is what we call power rating. Let's see some question. This question is asked in board exam. Define electric power and its SI unit. The two bulbs are rated 100 watt and 220 volt, 60 watt and 220 volt are connected in parallel. Okay, we have seen this question. The same question is repeated. Let's move to the commercial unit of electrical energy. So according to the law of conservation of energy, work done by electrical current is equals to electrical energy consumed. So electrical energy is equals to power multiplied by time. We know that power is equals to energy over time. So energy is equals to power into time. So energy can be measured in watt second. Watt second is called joules. But commercially, the unit of energy is kilowatt hour. So electrical energy consumed by an electrical appliances depends upon two factors: the power rating of appliance and the time for which the appliance is used. Like for higher power rating of the appliance means it will be consuming more power, and if you use the appliance for the long run, then also it will consume more energy. So this watt hour, 1 watt hour is the amount of electrical energy consumed when an electrical appliance of 1 watt power is used for 1 hour. Commercial purpose, we are using a relatively bigger unit, and the commercial unit of the electrical energy is kilowatt hour, and 1 kilowatt hour is equals to 365 times 0 joules. Fine. How do we define it? It's very simple. We know that 1 watt second is equals to 1 joule. Fine. So 1 kilowatt second would be equals to 1000 joules. Just multiply the 1000 both the side, and 1 kilowatt hour means is 1000 multiplied by 3600, this much joules. It means it is 36 multiplied by 10 raised to the power 5 joules. That is 3.6 into 10 raised to the power 6 joules. So this is equals to 1 kilowatt hour. And this 1 kilowatt hour is called 1 unit of your electricity bill. So that is why the kilowatt hour is taken as the commercial unit. See this question, calculate the total cost of running the following electrical devices in the month of September. So in September month, we have 30 days. So the device is used for 30 days. Now what we have to calculate, if the rate of 1 unit of electricity is 6 rupees, electric heater of 100 watt for 5 hours daily. Okay, so if we calculate the energy for the first one, energy is equals to power multiplied by time. Fine, so the power is equals to 1000 watt and the time is 5 hours daily. So to convert this watt into kilowatt, we have to divide by 1000. Now it is in kilowatt. 5 hours daily for 30 days multiplied by 30. So this is the value we are getting. This 1000 get cancelled out. So it's 150 kilowatt hour. Fine. This much amount of energy this electrical heater is going to consume in the month of September. So the cost of it is equals to how much? The cost would be equals to, for 1 unit, it's 6 rupees. So for 150 unit, because kilowatt hour is 1 unit only. Fine. So 150 kilowatt hour means it's 150 unit. So 150 multiplied by 6 is 0. ₹900. Now let's see the second part. Electrical refrigerator of 400 watt for 10 hours daily. The energy consumed by the electric refrigerator is equals to power multiplied by time. So it has a power of 400 watt. To convert this in kilowatt, we have to divide with 1000. 10 hours of daily for 30 days. So this 1, 2, 3 zeros get cancelled. So we will be getting 120 kilowatt hour. Now the cost would be equals to 120 kilowatt hour means it's consuming 120 units. Now the cost of 1 unit is 6 rupees. So for 120 unit, it is 120 multiplied by 6. So it's 720 rupees. This is the cost of the electric refrigerator for operating it for 30 days.
If you like this video, you will also like PracBee's unique one-on-one last mile journey program. In this program, we sit with the student, understand their preparation till this point of time. And based on that, in step 2, we write a customized planner just for you to help you optimize your mark based on whatever preparation you have done. In the step 3, we sit with you one-on-one by a set of faculties aligned by PracBee and help you implement the customized plan that we wrote for you. Students have come to us with limited, no or good preparation and all have been able to score their marks to a large extent. If you think that this seems interesting to you, click on the link below in the description, fill the required details and somebody from my team will get in touch with you.